Hey there, in this video, we shall be discussing a cross-topic question involving differentiation, chain rule, rates of change, increasing and decreasing function, as well as quadratic inequalities. In part A question, we have this. The variables x and y increase in such a way that when x is a particular value, the rate of increase of y with respect to time is half the rate of increase of x with respect to time. Given that y equals to 2 square root 6x plus 7 over 3, find this particular value of x, and that is a 3 marks question. In a separate part B questions, the drug concentration C of t in a person's bloodstream t hours after digesting a certain amount of drug can be modeled by this function C of t equals to 0.845 t minus away 3t cubed over 200. Find the time interval when the drug concentration in the bloodstream is increasing, and that is a 4 marks question. Now, you might want to pause this video to give this question a try, and when you're ready, keep watching. Now let us begin this part A question. As you can see over here, y is equal to 2/3 square root of 6x plus 7. There is a 6x plus 7 and there is a bracket, a whole thing to the power of half. In this case, we are also dealing with the rate of increase of x as well as the rate of increase of y. That means to say, we are required to do a differentiation, and this differentiation involves a chain rule. So let's recap a bit on our chain rule differentiation here. So by chain rule differentiation, over here, if y is equal to a brackets fx to the power of n, your dy over dx will therefore give us a n. So this n actually comes from the power. Bring down power, this n, multiply by fx to the power of n minus 1. Bring down power, power minus 1. Multiply by the differentiation result of what's within the bracket, in this case, f prime of x. Putting everything together, our dy dx will therefore give us a, bring down power, power minus 1, multiply by the differentiation result of what's within the bracket. In this case, we state it as f prime of x. With this in mind, we can then start to do our part A question. So over here in part A, we can rewrite our y into indices form like this instead of living in a Surds form. So you have a y equals to 2/3 6x plus 7. A square root means it's the power of half. So once we write it in the indices form, we are able to bring down power, power minus 1. That will be so much easier in this case. So let's do a dy dx. By dy dx over here, 2/3 remains. The power is a half. So bring down power, and power minus 1, 1 minus half is actually a negative half. Power minus 1, multiply by the differentiation result of what's within the brackets. Differentiate 6x plus 7 over here should give us a 6 in this case. So bring down power, power minus 1, differentiate and multiply by whatever that is within the bracket, differentiation. And there you have it. So what we can do now is to simplify 2/3, half, and 6. So our dy dx will therefore give us this part. 2 divided by root of 6x plus 7. So this is my dy dx. Let's continue with this question over here. The question also says that the rate of increase of y with respect to time is half the rate of increase of x with respect to time. This means to say that dy dt is half of dx dt. So dy dt is half of dx dt. This is given in the question. Now, if you have to shift the dx dt to the left side, we have this equation. So over here, the dx dt is a multiply. When I shift it to the left, it becomes a divide. So dy dt divided by dx dt shall give us a half. Now let's simplify this thing further. The dt at the bottom divided by dt here at the bottom here is gone. You're now left with a dy divided by dx that will actually give us a half. So when dy dx equals to half, and we have found our dy dx earlier, now what we do is we equate these two green color highlighted equations together. For your dy dx, we have this, and solving for your x should give us a 1.5 like this. And that is the answer for part A. Now, going on to part B, which is an entirely different question. In this case, for part B, it requires us to find an increasing functions. So let's recap on increasing function within the differentiation topic. So over here, by increasing function, it means to say the first order derivative, a dy dx, must be greater than 0, because increasing function implies a positive gradient, and by positive gradient implies dy dx to be greater than 0. Now let's continue with this question. Over here we have a c of t written down in part B. So this is my c of t from the questions. And in the next step, what we do is we know that the first order differentiation can be now known as c prime of t, because they ask for increasing function. So in fact we set the first order derivative of c of t, which is c prime of t, to be greater than 0. So what we want to do now is to differentiate this part here. So when we differentiate this part, we will get this result. So differentiating a 0.845t shall give us a 0.845. Differentiate a negative 3t cubed over 200 over here. Power of 3, bring down, 3 times 3 is a 9. Power minus 1 becomes a t squared. So over here, we have a 0.845 minus a 9t squared over 200. So take note of the inequality sign is greater than. Now over here, in the next step, I'm going to multiply by a negative 200 throughout this entire inequality. So when you multiply by a negative number, we need to flip from a greater than to a lesser than like this. So multiplying by a negative 200 should give us a negative 169. Multiply by a negative 200 over here should give us a 9t squared. And over here, from greater than is now being flipped to lesser than. So this is in the form of a squared minus b squared. So we will need to factorize using the special algebraic identity, which is a plus b times a minus b. So we will therefore have a 3t plus 13 multiplied by a 3t minus 13 to be lesser than 0. So this is once again our quadratic inequality. So let's recap on our quadratic inequality. So over here we do have a happy face of 9t squared. So the coefficient of t squared is a positive, so we know that it's going to be a happy face shape. So let me draw the quadratic inequality over here. Alright, so this is my t-axis like this. If I set the first bracket to be equal to 0, I will have a negative 13 over 3, which is the same as negative 4 and 1/3. Set the second bracket to be equal to 0, I have a t to be equal to 13 over 3, which is the same as 4 and 1/3 in this case. Now the question says that our inequality says that it's less than 0. By less than 0, we are referring to this part of the quadratic inequality, whereby it is within one range, which is in between from 4 and 1/3 to negative 4 and 1/3 to a positive 4 and 1/3 like this. So writing it in an inequality form shall give us this answer like this. But wait, what exactly is t? So over here, going back to the question, t represents hours. So t can be a 0, but it cannot be a negative. So because t must be more than or equals to 0, alright, t must be more than or equals to 0, we ended up having this inequality like this. So t must be more than or equals to 0. So therefore, t is in between 0 inclusive to lesser than 4 and 1/3 like this. And that's the answer for part B.